We talked about three types of analytics. We'll look at three examples. Descriptive insights. When are people born in the US? This is a question we were grappling with. We wanted to understand, is it completely distributed throughout the year or not? We had 25 years of data. We created this visual with the data. So you have the months laid out across the rows, Jan to December, and you have the days of the month, 1st to the 31st. High number of births is a dark shaded cell. Lower births is closer to white. What do you notice here? Most births seem to happen between July and September. September actually has a very high birth rate. You can see the shades consistently dark. So you can conclude that conceptions might happen here during the holiday season. But there are a few other patterns which also stand out. For instance, very few births in these two patches. This happens to be the Thanksgiving holidays and the Christmas holidays. So we were curious, and then we were wondering, how can you actually push the birth dates out? And then we found out that the majority of births in the US are C-section. So the health professionals don't want to spoil the holidays, and they are able to move these slightly as much as possible out of this vacation window. And it's not just the health professionals, it's also parents. They don't want their kids born on April Fool's Day. So they move it out of April 1st. You see the patch here, it's a lighter patch. Or they don't want them born on 13th of any month. You can see again, this is lighter. But 14th, Valentine's Day, seems to be popular. So this is the pattern for US. We were curious, how does it look for India, where we had a treasure trove of public data? This is what the pattern for India. So you can see here, it's completely different. What do you notice? A lot of births, very few births in the second half of the year, a lot of births in the first half. Now we went about asking the second question, why are the births so skewed? So now we're getting into the why question, which is diagnostic analytics or diagnostic insights. This is the second advanced level of analytics. So here we do fraud analytics. So we started seeing a few patterns. If you look at the 5th, 10th, or 15th, the round number dates, there is a striking birth pattern where the high number of births on these dates, it's unmissable. And statistics says that when you notice patterns like this, there is an external influence. It cannot be natural random data. So we knew that something was happening behind the scenes. And then when we investigated further, we found out that this is actually related to the school system. In India, schools start in June. Any kid born in the second half of the year misses school. So the parents move the birth date artificially. Until a few years back, it was easy to change the date in the records. So they move it after the kid is born, they move the birth date to the start of the year so that the kid doesn't lose a year or close to a year of school. So that's what you see here happening. And this again is where you see the doctored birth dates coming in. Data can reveal a lot. And we are talking about simple visuals and simple statistics. So that's diagnostic analytics. Now let's get into predictive analytics. What can we use data and analytics to find out what is likely to happen next week or next month? So I'll walk through a live example. So working with a cargo carrier, the challenge they were facing was from the time flights land, how much time do they take to move the cargo from the airport to the warehouse? So they had a SLA of 1.5 hours. They wanted to find out what was causing the delay and what actions can they take to improve it. So is it the shift? Are morning shifts or evening shifts taking more time? You can see that the color coding, green means it is doing well, closer to red, it's not doing well. You can see that morning shifts are not doing well, particularly Friday mornings. And anything which is ZDH on a Friday morning, ZDH is fragile category. Any fragile item shipped on a Friday is taking time. And any fragile item which is part shipped, less than 20%, takes the most time to handle. So now with visual analytics, you've identified the root cause. What do you do about it? If I increase the number of trained staff from 5 to 6 or 7, what happens? This is where simulation and predictive analytics kicks in. Now it says, assuming I have 7 people, how much time would it take on a Friday morning or to handle fragile items? And then it comes up with certain recommendations and says, by the way, when you have 7 people, most of these flows turn green. So you check whether this is an acceptable level to meet your SLA and you move on. So this is an example of predictive analytics.